going live? Perfect, perfect. All right, there we are. And hi, everyone. Hello over there on YouTube. Great to see so many people attending. Okay, extremely sorry for the delay. We were busy in setting up few things. Cool. Feel free to ask any question. Those who are on YouTube, feel free to ask question there. And please feel free to introduce yourself over the YouTube chat as well, if you are watching through YouTube. Wonderful, wonderful to have so many people. And let's start. Great. All right, let me share my screen. All right, hi everyone. A question from Prasanta is that I want to know more about semantic search using LLM. And I would love to answer it in more detail at a later point of time. So feel free to hold on your question towards the end. I would love to answer those questions. Wonderful. All right. So everyone, welcome to this session on LangChain. We are going to talk briefly about how to use the OpenAI via LangChain. And this is, very important to know that LangChain is like a middle layer between you and the various AI APIs. Okay. All right. This is the format of the session. I'm the speaker. I'll talk about myself later. So we'll talk about CloudxLab, then we'll talk about what are LLMs, and then we'll talk about ChatGPT. Then we'll do a brief introduction about LangChain, and then general applications of LangChain, and we'll try to do a hands-on project on LangChain. The session is approximately 1 hour, 2 hours, but I think this is going to go for 1 hour. And except for myself, everybody is on mute. So please use the Q&A as well as chat to ask questions. The recordings and slides will be shared after the session. So you can also, annotate, you can take the screenshot, you can, yourself record the screen and feel free to publish it socially. And I mean, whenever you're publishing it, do not forget to give the credit. Okay. Yeah. Thank you so much. All right. So the certificate for this webinar will be provided from CloudxLab to attendees only on successful submission of the attendee attendance form. So we'll be sharing the attendance/feedback form. So please fill that form and you will get your certificate. Okay. All right. About myself, I'm founder at CloudxLab, and I am actually the head of AI at DevRev. It's a startup. And I love explaining technologies, and I have been the AI leader and software engineer at Amazon, InMobi, and DESH in past, along with my own startups. So I have worked on large-scale computing, machine learning, and AI in past. I graduated from IIT Roorkee. So you can reach me at LinkedIn. That's my QR code, but you can just search for Sandeep Giri and you can find. Okay. So Okay, that's very strange that there is no name for me. I will, you know, I'll just put my name here. Yeah. You can reach me on LinkedIn as well. So perfect. Now, so briefly about CloudxLab, our core vision is to upskill engineers. We have actually upskilled more than 300,000, that is 3 lakhs of engineers so far. People have attended our workshops, people have attended our webinars, people have attended our courses and have used our lab. And we have been successful in making many people successful. Okay. And the core idea behind CloudxLab is a playground whereby you have everything at single place. On the right-hand side, you will see the lab, and on the left-hand side, you will see the assignment. And once you finish it in the lab, it gives you the feedback that you are done well. Along with that, instead of this, you can also, tinker around with any tool directly. So if we give, at CloudxLab gives you a real world experience, seamless experience, central data set, any device, anywhere. Next is you can as you work on CloudxLab, you will get your social profile up, and we have a dedicated job portal. And there is something called exams. We keep on publishing the exam, and people attend to those. And those who do well, we connect them with the industry. Next is now let's come back to the core topic today. What are the LLMs, large language models? And large language models are basically the state-of-art AI models designed for processing and generating text. Okay. In our past webinar, we talked about how do actually large language models work. And so large language models, they started as, the word complete or predicting the next word from a sentence. And they turn out to be very successful at answering questions. And they excel in language comprehension generation. The large language models such as GPT, they possess the contextual awareness. Large language models are trained on large data set, granting them access to a wide range of knowledge and information across various domains. Now, you might think that the every data is large, so why now? Why did this miracle happen now? The data has been available for very long, right? Nobody has stopped people from downloading the internet and start using that data, right? Why now? So that might be a question that would be going on in your head. The thing is that the processing power has become popular. People realize that better neural networks, such as transformer models, seem to work pretty well. And people also realize that if you basically the language models can be done in an unsupervised or semi-supervised way. Okay, so you have humongous text from the internet. You build a model that given the sentence so far in this paragraph, predict the next word, right? And that way, from the unstructured data or unsupervised data, you are able to build a supervised tasks. Okay, and that makes it possible to build the intelligence without providing supervision. Because if we were providing the supervision to the machines, the chances were we would basically not be able to produce that much data, right? So yeah. So basically the the secret behind large language models is essentially the autocomplete models. All right, just give me a moment. Here's a question from someone. And okay. Yeah. So basically, the large language models such as GPT, they have done wonderful in terms of understanding the language. And this is a miracle because none of the models from the history have done this great so far. So large language models are revolutionizing industries by several means, such as customer service, content generation, language translation, virtual assistant, and more. And the NLP model, the LLM, basically first came GPT. From GPT came ChatGPT after they, provided more supervised data, more supervision, and by using this strategy called instruct GPT, and that became ChatGPT. GPT knows how to complete a sentence. GPT knows how to complete a sentence, and ChatGPT knows how to answer the questions well. Okay, ChatGPT is basically slight modification of GPT. Okay, GPT is generative pre-trained transformers. Okay, essentially, we are training a model called transformer on a humongous data to predict the next word from previous words. And we are doing it over and over from using the data from internet. Or you can think of it that we have a sentence, we want to predict the last word from the rest of the words, and we're feeding the rest of the words, and we're expecting it to produce that particular word. Like, for example, I'll just try to make it very brief. Okay, imagine that neural network is this bunch of knobs. You have this bag of knobs, so you can think of big set of knobs, and these knobs as in something that you can twist. You remember when you take bath, you twist the knob, right? So you twist the knob so that you can get good water to take bath, right? In winters, it's more important that you have like right amount of water, right amount of temperature to take bath. So you twist these knobs and figure out, okay, what's the best flow and what's the best temperature for you. And then exactly that way, so what we do is we tweak these knobs of neural network, and knobs are nothing but numbers being multiplied with the flow, right? So these are called weights. Those knobs are called weights. So we tweak these weights in order to get results, right? So we basically take a sentence. Let's say the sentence is, this is a cow, right? So we'll feed this as in this word called this. We'll feed this and ask the neural network to learn to produce is. So it'll learn, okay, after this comes is. Then you feed this is, and you expect it to give a, right? Right? And then after that, you will feed it, this is a, and say cow. So we will twist these knobs to teach it that if somebody is entering this is a, you have to say cow. And that's how the LLMs or large language models are trained. And once you have trained this neural network model on entire Wikipedia or internet or Quora or everything, you have this model which understands probably everything. Okay. And you feed something like, sentence of 2000 characters or tokens, we call them, and then you make it produce the next word. And that way, it learns how to complete a sentence. Okay, that's LLM. Now, what people did at OpenAI, they took LLM, like GPT, and told it that end of the question is this particular symbol. Okay. So after this particular symbol, it starts auto-completing. So you think that ChatGPT is answering your question, but no, it's actually just auto-completing that sentence, right? That paragraph or that input, it's just auto-completing it. It's just that the end of the question is also one of the words that is being fed to ChatGPT saying, hey, when the question ends, you are supposed to answer like this. And that's how over a lot of question answer databases, ChatGPT was fine-tuned. GPT was fine-tuned on that huge good questions to start giving the answers to the question. So that's how ChatGPT became question answering model. Okay. And it turned out to be very, very successful. All right. Perfect. Perfect. So I hope I was able to explain to you without using slides, and would love to answer your question. And yeah, great, great. Now you must have seen ChatGPT. Those who have not seen ChatGPT before, I'd love to give you the demo. Okay. So you can see here is ChatGPT, the interface, and you can ask any kind of question. You should not hesitate at all, just trying it out. This is free and this seems to do well with everyone. Okay, so there we go. I'm going to put it on the YouTube as well. Okay. All right. So here we go. Basically, the core idea here is to just test out what's happening there. Okay. Now, okay, right? Okay. Anybody wants to ask a question? I'll just copy paste that question. Okay. I'll try to turn off my video because it's coming in the midway of some of the attendees. Okay. Let me see if I can pick up somebody's question from YouTube and answer it here. All right, let's see. Okay. Yeah. So like, for example, Prasanta was asking about this. I want to know more about semantic search using LLMs. Okay. You see that? Okay. Now, isn't that fantastic? All right. Let me see if it can answer a question about itself. I'll actually answer your question later. Okay, Prashant. Right? This is the question from somebody else. And now, isn't that intelligence? It's just fantastic. Okay. All right. So you can see that it's not really answering your question. If you think about ChatGPT, it is not really answering your question. It is just auto-completing things after end of the question token that has been sent to ChatGPT, right? All right. So you can also try all kinds of things. I was surprised to know that it actually knew what is CloudxLab. Okay. And it can do really cool things like writing a rap song related to programming. And basic programming tasks, such as inverting a binary tree, is also possible. You'll be amazed to see the kind of experiments. Now, how to customize LLMs to build your own application. Okay. Now, so first of all, all of these things are directly possible using OpenAI. Okay. LangChain provides a middle layer to get things done. All right. So basically, you can take a look at, say, for example, if you go to platform, OpenAI, okay, and you can go to say API keys, and yeah. Hi everyone, I'm going on mute. Hi everyone, I'm going on mute for a moment. Okay. All right. Yeah. So I'm just trying to, set my payment in my account so that I can start using OpenAI as is. And that's why you'll have to hold on so that I can give you a proper demo. Okay. All right. I'm trying to set the payment gateway so that I can, show you the demo. Yeah. And I'll try to just finish that part. All right. So because I need to send the billing, and I hope my screen is not shared. Okay, perfect. All right. So, okay, like if you want to take a look at how does OpenAI work and all, just go to platform.openai. Okay. I would want everybody to basically try their hands-on with OpenAI itself directly. And that way you are all, you can be more comfortable with trying out things. Okay. So there, okay. So I'm going to do a couple of hands-on. There might be glitches with respect to the keys and other things. Sometimes there are glitches. Okay. So let me put it on the YouTube channel as well. Okay. So there we go. All right. Now, why I want everybody to give it a shot to, first just bare minimum of OpenAI. Okay, because there are many good resources to understand multiple things. One is when you go to platform.openai, you will find these great tutorials. I really like their embedding tutorial that basically you can test it out and see how it works and not. And basically that's the idea, right? And it's actually pretty important to just start, tinkering around with the models. Okay, it's not something forbidden, or it's not something that you need to worry about. This is just available to all of you. Specifically, take a look at their OpenAI cookbook, and there are quite a few very useful things. I'll talk about embedding, I'll talk about other things very soon. Okay. And also you can take a look at, say, here, if you go for documentation, you can take a look at their documentation. These are the various, API and tutorials, and you don't have to, you can just experiment with it. Okay. And where do we start? So you can take a look at, say, here. You can go over to this and start your own environment, and then you can just start experimenting. If you have a basic idea about Python, that'll be good to start. You can just get going. Okay. Now, let me, yeah. Right. So probably before you jump onto the LangChain, I would want you to go over these examples and other things. Okay. All right. I'm going to show you something here. Okay. So this is the core OpenAI API. Okay. So you should make yourself comfortable here. You can take a look at your keys by going there. Right now I am in the personal. I can switch that to CloudxLab. Okay, that's the organization that is there. And these are the secret key. You can create a new key and, and start using that key. Okay. Let's say I'm just saying test key and done. Okay. So as simple as this. So you can essentially create a new key and start using it. Now moving ahead here. Okay. Now, what I showed you that it is very much possible to use OpenAI directly, but we want something in between, and that is LangChain. Instead of directly using OpenAI, people prefer to use LangChain. It provides multiple things. Okay. LangChain takes language learning to the next level by integrating large language models. It takes GPT-3, such as GPT-3 or GPT 3.5, whatever is available via OpenAI, and it has the ability to generate human-like text by using those LLMs. LangChain harnesses the power of LLMs to create advanced generative AI and chatbot technology. Now, you might say that all of that is done by LLMs. It's not a property. It's not a property of LangChain per se. It is basically, the LangChain is like a middle layer. You call LangChain, LangChain calls the particular vendor. Okay, because there are many vendors which are similar to LangChain, similar to OpenAI right now. There is Bird, there is Anthropic, there is there are some more Hugging Face models and so on. So there are quite a few models that you can just interact with via LangChain. Let's say today you are using OpenAI as your language engine, but tomorrow you want to move to Bard. You can just change that in LangChain and none of your logic will change. Okay. Now, the other thing is the LLM can connect to your data using vector database. Okay. So I'll talk about this a bit more. And let's say, what does it mean by a vector database? Okay. People have asked this question before. I will answer that question. And there is this thing, somebody has asked me this particular thing. Okay, here is a question that I want to know more about semantic search. Okay, all right. What does it mean by semantic search? Let me start there. Okay, so this is a question that somebody's asked. So I'll try to keep it simple, right? And we'll try to match. Okay, let's say there are 3 sentences. Okay, and okay, and okay, so this is Queen of Hearts card. Okay, there is another sentence. I'm just saying, giving you an example. Okay, this is Queen Victoria, Queen of. There was Queen of England and okay, so we have 3 queens, right? This queen, this queen, this queen. And if somebody's searching for let's say, can you tell was there ever some okay, I'm just adding to this this particular thing. I'm just adding to it saying named Victoria. Okay, now okay, now somebody says that can you tell a name of queen, name of a queen of a state, okay, or a country, right? So this is my sentence, and these are the data I have. This is one sentence, this is another, this is another. Which one should it match? The first one, second one, or third one? This is my question. Yeah. Yeah, please reply on the chat, everyone. Which one should it match? So you have these sentences, 3 sentences. This is a Queen of Hearts card. There was a Queen of England named Victoria. There is a Queen bee. Now, question is, can you tell a name of a queen of a state? Correct? So it is second. But when we did this keyword search earlier, the queen will match with any of these, right? All of these. Remember the Google search engine earlier one? Basically just look up on the keyword. So that was syntactic search, correct? That was syntactic search. What is a syntactic search? Searching by keyword as is. Okay, syntactic search, right? By comparing the keyword. Now is the time of semantic search. Okay, what does it mean by semantic search? Right? So imagine this sentence getting converted into some numbers. All of these sentences getting converted into some numbers. This is 0.6, 0, and so on. All right. And so on. So imagine that language model, after understanding the sentence, put them into a bunch of numbers. It gave them numbers such that the things that are closer to each other, they are nearby. Those things that are farther away from each other, they are meaningfully. Okay. So, right, let me just draw another example to give you a context. Imagine that, let's say, imagine that instead of many dimensions, you have only 2 dimensions. Okay. So imagine that there is a cow. Okay. There is cow. There is buffalo, and there is goat. Goat is a bit far, and there is human. And there is man, there's king, let's say frog and toad. Okay. So what these language model do is they come up with these bunch of numbers representing each of these words, okay, each of these words, such that the words that are existing in certain context, okay, in similar context, they come nearby, right? They come nearby in that space. Are you comfortable with the visualization? So they come up with these coordinates of these sentences or words such that these coordinates which are existing nearby are more similar to each other, while these are far away. Got it? So this distance, this distance, this distance, this distance, right? And this distance, right? So which one is smaller? This, let's say A and B, which one is smaller? A, right? So sheep is closer to goat. So if we compute the distance between them, that basically represents our, how far is it? Okay. So what you will do, you'll convert it to a bunch of numbers, you'll convert it in a bunch of numbers, you'll convert in a bunch of numbers, then you'll compare, and also the question that came in, we'll also convert that into a bunch of numbers. And then what we'll do, we'll find the distance between this, and this. Okay. And say, this one is closest to this question, right? Similarly, if we are looking for something very closer to frog, we'll compare it with man, find this distance between man and frog, find this distance between man and human and frog, sheep and frog, goat and frog, buffalo and frog, cow and frog, and then frog and toad, and find out who is the closest one to frog. Okay, this is called, like finding this distance is called semantic matching, because we are comparing these numbers. We call them embeddings. Okay, we call them embeddings. These are called embeddings, right? Embeddings are essentially representing text by numbers based on the meaning. Okay. Semantic matching is this distance. Okay. Sometimes you will see two kinds of distances. One is this direct distance. Other is the angle. Okay. Like, for example, the other similarity way could be that we basically find this angle between these two data points. Buffalo and cow, we basically find the angle. Okay. Right. So essentially, the way it works is that we, instead of putting it like everywhere, we basically put these numbers on a circle such that the angle between the points as well as the distance between the point, both are representing the same thing. Okay. Usually this distance is called Pythagoras distance or Pythagorean distance, or sometimes it's also called L2 distance. Okay. This is L2 distance. Okay. So it's simple. When you are looking for something in your database for which is matching a particular sentence, what do? Go over the embeddings of all the things, compare it, and then pick the closest to you. Correct? Now, this seems to be too much of work. Okay? This seems to be too much of work. This is where the ideas like vector store come into play. Vector store makes it possible to compare quickly by making sure that by keeping the index of these data points in a cleverer way, so that you don't have to compare with everything. Instead, you will only compare with the things that are nearby. Okay. So you basically create groups of data, and then you basically, let's say, you want to find out what is nearest to, let's say, this data point. Okay. Let's say this is, okay. Let's say there is a thing called, what is that thing called? Yellow frog. Okay. Yellow frog. Okay. Let's say there is one keyword that came in, yellow frog. Okay. We want to find out who is closest to yellow frog. What we will do, we have two options. One, comparing this yellow frog data point with finding this Pythagorean distance or cosine distance, the angle between these things. This is called cosine distance because cosine of this angle. Okay. Okay. If this angle is 0, then cosine is 1, which means very similar. If this angle is bigger, cosine of that angle is, cosine of, if the cosine is, the angle is smaller, these things are very similar to each other. If the angle is bigger, these things are very far away from each other. Now, so when we are, let's say, looking for yellow frog, what's closest? One is, do we scan through entire thing and then do it? Instead, there are these things called vector data store. What they do, they take all of these embeddings or all of the, semantic embeddings, or sometimes also called, what do you call, there's another word for embedding. Okay, let's just skip that part. So what it does, the data store, vector data store, what it does, it takes these the embeddings of all these sentences or words, put them in sort of groups. It figures out that there is one group here, one group here, one group here, okay, and one group here, okay, and then it has center of all these groups. Okay, it has center of all these groups, and what it does is it tries to find out the closest group to this one. Now, instead of comparing these 8 things, now it has to only compare 4. One group, second group, third group, fourth group, right? And then quickly it can just try to find out here. Now, some of these vector store again divide each of these groups into further groups. We call that using something called k-means clustering. That's an algorithm to find out the groups in the data. So it basically create groups of the data based on this algorithm called k-means, and then put them, keeps the center of all of these groups. And inside each of these groups, it again creates the clusters, and it just keeps on doing it over and over. That's called indexing. Okay, that's called indexing. All right, or you can say semantic indexing. All right, semantic indexing is to make the semantic search faster. Okay, it makes it really, really fast. So there are so many vector stores as of now. Like, for example, one is Milvus. And there are quite a few ones that are there. You can just take a look at, if you go here, I'll just save all of this. Okay. If you take a look at, say, vector stores, okay, vector stores. So these are, right, these are the various kinds of vector stores available. I'll just show you. Vector stores. Or does it? It doesn't give you that list, but I'll just show you. Be with me. Like, one is pine cone. Okay, take a look at the pine cone. And where is other? I remember there was a nice data store website. Okay, never mind. I'll share that list of data stores. List of vector stores. List of vector databases. Okay. Yeah. So there are quite a few available. One is by Google. One is there is Quadrant. There is VWeight. There is Milvus. There is Elastic. Okay. So you can compare those based on your requirement. You can pick it. Okay. All right. So I hope everybody is clear about, I talked about many things. So LLMs, the one that we talked about just now, the large language models, they not only give you the text as answer, they can give you a bunch of numbers called embedding, right? Or vector embedding vectors, right? So they give you these bunch of numbers representing the meaning of a sentence, okay? Like sometimes it'll keep all the, let's say, good morning, good evening is very closer to each other, while as opposed to how are you, and similarly how are you and good morning is very close to each other as opposed to what is your name, and so on. So you can basically, it converts the OpenAI API and other APIs. They give you the embeddings. Okay, you can turn a language into embeddings. Okay, and embeddings are nothing but vector, and you can do all sorts of mathematical things on it. Like, for example, searching for a similar sentence, that's a basic primal use. Then you can apply another kind of complex models to find out the, let's say, to do the classification. Let's say you are trying to do the classification of a sentence, whether this sentence is good or bad, and you want to rate this, or you want to rate the sentence between 0 to 5, and so on, right? So you can do all of that. You can apply models, train models on top of embeddings, and get it done. So I would strongly recommend everybody who is trying to get their hands dirty with the LLMs to know about embeddings. Okay, so I talked about quite a few things. You can watch this video again at your own time, and then get an idea about what's going on. I talked about vector data store. I talked about the how does vector data store indexes the embeddings and so on. Okay. All right, I'm going to clear this now. I hope I was able to give you an answer. There are many open source vector data store available, such as Milvus is good. There are quite a few available for free, so you can just use them. You don't need to really buy or subscribe to any sophisticated one. But if you are a large organization where your requirements are very stringent when it comes to performance, then probably you would like to go for something like a subscription-based system, such as Pinecone or something. Okay. All right. Did I make sense? Give me some emoji to express your state of mind. Is there an icon or something here? All right. All right. Now, moving ahead, I wasn't really, I did not prepare slides for explaining the embeddings. Okay. All right. So this is where we digressed. And I think this digression was nice. And I hope it'll be useful. It's very, very important concept called semantic search, semantic comparison, or semantic matching. Okay. So comparing two things based on their meaning rather than syntax is something that's extremely, extremely important. Similar thing happens in case of images, right? Giving two photos of a person, maybe one is of 5 years ago, one is of now. Even though pixel by pixel, they are very different, but they are very similar, right? So there again, the idea of embedding comes into play. There are many machine learning models or deep learning models that convert the photo of a person into embedding, such that the photo, like if the photo belongs to the same person, they are nearby mathematically, otherwise they are far away. The same idea of embedding applies there as well, but of course the models are different. Here we are using LLMs to convert the text into a bunch of numbers called embedding. There we use FaceNet or other models which convert the face into a bunch of numbers. Okay. There are many applications of LangChain. I'll just talk about it. One is building your own personal assistant. Okay. You can build your own personal assistant, customize according to your requirement, can take action, remember interaction, and have access to your data, and provide personal assistance. Second, doing the question answers over documents. It can ask and chat and ask. You can chat with the documents. Now, how does that work? Okay, how does that work? When you ask a question, right? It exactly works like this, okay? So what you do is you go over the entire, you go over the entire database of text and break it down into paragraphs and convert each of the paragraphs into a bunch of numbers, okay? Now you have these bunch of numbers in your database, vector database. And when a new question comes from the user, what you do is you convert that question into a bunch of numbers called embedding, and then using OpenAI API or LangChain API, and then you compare that with each of them, or cleverly use the search, or cleverly use the indexing so that you can do the minimize the comparisons. So you basically take the sentence, find out which sentence is the closest to it, and then based on that, you answer to the user's question. Okay, so that's kind of the strategy in case of building a Q&A model. Okay. So use information held within the documents to answer questions or query by storing these embeddings in the vector store. You summarize the long text and documents into concise information and so on, right? You can create chatbots. Okay. LangChain provides you these prompt templates that empower you to have full control over chatbots, including its tone of voice and communication style, as well as the responses it generates. Agents involve an LLM making decisions about which action to take, taking that action, seeing an observation, and repeating that until done. Okay. So you can create your own agent that does something. It keeps on calling other agents and keep on taking an action, right? If you have seen this crazy idea called AutoGPT, have you seen this AutoGPT? Take a look at AutoGPT. Okay. Perfect. Moving ahead. So with LangChain, you can create your own agents. Okay. LangChain provides standard interface for your agents, a selection of agents to choose from, and examples of end-to-end agents, right? Then you can also query data. You can query data stored in tabular formats such as CSVs, SQL databases, or data frames. Extract structured information from unstructured text, streamlining data analysis and interpretation. Then you can also interact with APIs. Okay. Basically, it is similar to what OpenAI provides right now. OpenAI right now provides you something called plugins. Similar to that, LangChain had always been providing you a way to automatically call the APIs or give you the code to generate it such that you can call these APIs. It simplifies the evaluation of generative models by utilizing prompts and chains within the language model themselves. Okay, so we are going to do a bit of hands-on. All right. All right, before we jump in there, let me try answering your questions. Okay. Let me open the questions. I've turned off the screen sharing. Okay. I'm just downloading some keys. Okay. And yeah. Just give me a moment. I'm just downloading the keys so that if I end up sharing with all of you, it'll be a disaster. Okay. All right. All right. Perfect. Perfect. Let me answer a couple of questions before I jump on to the hands-on demo. Okay. All right. A question from Ranjan is, okay, is there a difference if we use Hugging Face API instead of OpenAI? If you use Hugging Face API, you will be using their models, not the OpenAI ones. Okay. So a better strategy is to just use the LangChain API so that you can switch between Hugging Face and OpenAI quickly. You don't have to worry about, writing duplicate code. A question from Sachin is, so ChatGPT doesn't have thinking ability. It is just using algorithms to complete the sentence from the last word, okay? Yes. So basically, thinking ability, the way we define it, is important, right? If some people define the thinking ability to be able to answer questions, right? And there's nothing wrong in it. So from that perspective, it does have thinking ability, but how is the thinking ability built? The thinking ability is built by trying to answer the next word. Just like when we are reading a novel or a book, we basically try to guess the next word, and that's how we start learning the meaning of each word by association. Okay, so if you define the intelligence that way, it is, then ChatGPT is intelligent. But if you think of that intelligence as something statistical or something, something very, very rudimentary, then it may not be an intelligence to you. Okay. But it is considered as intelligent. A question from Ashim is, please delve a little more into how they know if words will come together. Example, sheep will be closer to a goat as there is so much data. Okay. I don't think it'll be supervised. It won't be a supervised model. So just like ChatGPT produces next word, okay, so there is an interim representation of each of these sentences, and that interim representation is very, very much close to their embeddings. So essentially, it's bunch of the embeddings are extracted from the deep neural network model, the autocomplete models, and that's how it is. Okay. There have been many strategies to find the embeddings in history. First strategy was, by fill in the blank, take a sentence, delete the first word, try to guess it, and then take the second word, try to guess it, then third word, try to guess it. And that's how the embeddings were generated, right? Similarly, the other embeddings were generated based on the frequency analysis, that this word mostly comes around these words, and therefore these two words are similar to each other. Okay. And there have been quite a few strategies. One is, just initially assume the embeddings to be random. Now, if two words are existing together, okay, right? If two words are existing in the same context, their embedding should be closer. If they are not existing in the same context, their embedding should be far away. So those numbers are automatically picked by the neural network for optimizing this logic. That if this word and this word have existed in the same context, that means these two words have the same embedding. In case of sentences, it's more about, given this sentence, if we are producing the same word, then this sentence has got the same embedding, okay, or similar embedding. So that kind of thing. So that's a topic for a webinar itself, that how these numbers are assigned. Okay, I would love to go into more details into it. Okay. A question from Prasanta is, single store is also known as vector store. Do we have to subscribe to vector data store for LLM? Not really. There is many data stores, as I said. If you are doing on a large organization and you cannot tolerate downtime or other things, then you can just subscribe to, say, Pinecone or some other professional data stores, professional vector stores. A question from Parth is, can we use LangChain in Python? Of course. And can we use LangChain in Python? So how do I use it? I'm going to show you that part. Is search engine optimization based on LLM? Search engine optimization as in like Google is optimizing its search using LLM? Yes. Are people using LLMs to improve their visibility of for search engine? Yes, that is also happening. Like, for example, many people are generating the content. People's content and strategies nowadays are around LLMs. And it seems that Google doesn't mind it. Google is okay with people generating the content using LLMs. Okay. I hope this, so far, everything is good. Great. Now, I'm going to dive a bit into hands-on. Can you see my screen? Okay. A question from somebody is it possible to perform user item interaction using LLM? As in, what do you mean by user item interaction? Do you mean to say that, let's say somebody wants to reset their password on your website? Can we do that using LLM? Okay. Yes, of course, that is possible. That, this is where OpenAI provides something called agents. You can make the call, they can make the API calls for you. All right. So you can basically give the API, describe the API, and tell the LLM to generate the functions, and you can take this function and make a call. Okay, that's very much possible. A question from Andrila is that, could you share a bit about hallucinations of LLMs? How can it be used in assistive capacity where trust breach is an issue? Can we use ensemble techniques to get around hallucination problems? Okay, so hallucination is, if you think about large language model, right? What it does, given a sentence, it needs to autocomplete it, right? And it tries to make guesses. It tries to do, just like what humans do. They try to take assumptions. It just tries to see, okay, in this context, what is the next word to say? Right? And a number of times, it would say things that you have not imagined. And it may say things that never existed. It may talk about things that may never existed. And that is called hallucination, or sometimes blatant lying. Sometimes people call it bullshitting. And so basically, hallucinations are real problems when it comes to LLMs. There are quite a few techniques to avoid hallucination. One way is having two models, or we also call, you can have multiple models, and we call that ensemble learning, right? Ensemble learning, or you can say a group of learners, group of models. And while one is producing the text and other is questioning that production, okay? Other is questioning the production. That's another technique to avoid hallucination. The other techniques to avoid hallucination is using by fine-tuning on your data set. By prompt engineering, you can explicitly say to ChatGPT or OpenAI model that, hey, do not go beyond these things. So the OpenAI itself provides you guide rails or control over the model by the way of clever prompt engineering. So first technique is prompt engineering. Second technique is by the way of setting the context. Do not talk about anything other than this. Third is by generating lots of question answers. That is something that I won't talk about because that's something that I'm working on. Then there is comparisons. There is comparisons of the results of multiple models, or having a police and thief kind of adversarial models to compare each other's results. So this is an area of research. Everybody's trying to do it. Then there is something called RLHF, reinforcement learning with human feedback, that is at the forefront of OpenAI to build the guardrails around each of the answers, each of the going out of context or hallucinating. All right. A question from anonymous attendee is that it can be built a collaborative filtering or recommendations using ChatGPT or other things. Good question. Good question. So, good question. I want to get into, I want to explain that to everyone. remember that I talked about so question is, how would you build a user item recommender or collaborative filtering using large language models, right? So imagine for a moment that you have, this database of places in a city, and you have description of each place, right? And you also have the databases of user and the ratings of each place. Okay, so you have say place 1, okay, and text of place 1, right? And then you have place 2 and description of place 2, right? And similarly, you have place 3 and the description and so on, right? So like that, you have all the places from Google Maps of a city and their descriptions, right? Also, you have the history of people. Let's say user 1 went to place 1 and gave a rating between 0 and 1 and said, okay, it gave 5. User 2 went to place 1, gave a rating of 3. User 3 went to place 1, gave a rating of 4. User 1 went to place 2 and it gave 5. Now, like that, you have the database of these, right? At the same time, you have the information about like description of person 1, okay? P2, and you have textual text description and so on. So you have description of a place, you have description of people, and you have the database of this person rated this place this much. The question is, can we use language models to build recommendation for these people or any other people in future, right? Answer is yes. How would you do that? Yeah, be with me. Okay. Imagine that you build a big matrix. Okay. So you will convert this into embedding. That's an array of numbers, or you can say vector of numbers, or you can say that embeddings, right? So what you'll do, you'll have, let's say, 64 numbers here, 64 here, and so on. Similarly, you converted this person description into 32 numbers, okay? So 64 numbers to describe a place and 32 numbers to describe a person. So how many total numbers? 96, right? So what you'll do, you will build this matrix. Okay, it has got say 96 columns, right? And against each column we have a database. Against each of these columns, right? Against each of these rows, not columns. Against each of these rows, right? We have got ratings. These are the embeddings of U1, P1. And these are the embeddings of U2, P2. Okay. So now you got the characteristics of the characteristics of the person and characteristics of the place, right? So characteristics of the user based on the description of the user and characteristics of a place. Now you got these embeddings, right? And then what you will do, you will basically do some sort of standard model fitting. Okay, you'll do the model fitting, right? this becomes like a classification task. In machine learning, this is called classification. Okay, using standard machine learning. Now, once you build this kind of data set, that these are 96 columns, based on that, we have to predict their value. And then when a new user comes in or new place comes up, we can compare that and test it out, whether which all persons will like it, and so on. Right? And this way you can do the classification on top of each of the pairs of user and place. Okay. In case you want to understand this process of like how do you build model using this, I would strongly recommend to take a look at CloudxLab courses. We basically have dedicated exercise and projects around these things. Okay. If you want, you can just take a look at, say, okay, you can just take a look at, say, CloudxLab. Okay, so you can take a look at the pre-guided projects or any projects, and here you can take a look at, say, guided projects. There are quite a few things here where, like, this one is a good process to learn for classification, no regression. Okay, and then you have classification project. So you can try these projects. This is another classification project. So you can take a look at these stepwise tutorials or projects in order to learn how exactly would you build a classification there. Okay. Good question. I hope this was useful. This is a good digression. A question from Parth is this difference between Chroma and LangChain. Oh, what is Chrome? I've not used Chroma yet. Okay. I think you're confusing. I think if this is Chroma DB, it's basically a vector data store, not a substitute to LangChain. LangChain is like a layer between the language models. A question from Path: what are the advanced features and customizations in LangChain? I would strongly recommend you to going over the LangChain API. I think because the advanced features keep on getting released every now and then, and it'll be better to just take a look at that. Okay. All right. I hope this is useful. I'm not. Let me take a look at the questions. Okay. All right. Moving on. Okay. I'm just going over this. All right. All right. Looks like the questions on YouTube are being answered well. Moving on. And okay, let me share my screen. Okay. We're going to create a ChatGPT clone using LangChain and OpenAI LLM as per the hands-on idea here. Okay. So first of all, those who are new to Python, I will walk you through what is going on here, right? So what you usually do is you basically create a virtual environment. I'll delete my previous virtual env. Okay. So what exactly is virtual environment? Everyone? Let me see if anybody knows. What is virtual env? So what we're going to do is we're going to do a brief hands-on, and we're going in stepwise fashion. So usually what we when we are building any project, usually we create this virtual environment because for this particular project, we might have to install other things, and we do not want to disturb other APIs and other packages that we've installed, other libraries that we have installed. They might get disturbed if we basically install, in general environment, we install everything. Those who are from old times, they would know the DLL hell that used to be in Windows, that one installation messed up with another installation, right? So that kind of mess you do not want. Therefore, you usually do that. A question from Path. Yes, with respect to the Pinecone, yes, it uses the LangChain can use the Pinecone. Okay. Question is LangChain based on blockchain? No, the only word is chain. Common in them is chain and nothing else. Okay, moving ahead. Yeah, thank you, Prasant. So I'm creating this virtual environment right now. There we go. So it has been created. Now you can activate it like using either source. So it creates a file, it creates a folder called venv because we gave the name as venv. And then we are saying bin activate, meaning activate this environment. The moment I activate it, let me increase the font. Okay. The moment I, activated, it basically created a folder called venv. It basically shows this prompt called venv here. If you deactivate, I'll go back to the prompt. This prompt, you can see difference in the prompt. I'll activate again. Now I'm in that virtual env, right? It's nothing but it just sets the path and other environment variables, nothing else. Now, moving on to another folder called LangChain, where we are going to build things up. Okay. In this, this is the keys file. Okay. I'm going to talk about it in a moment. Now we are going to install LangChain and OpenAI. Okay, both the packages now. So using pip install LangChain OpenAI. So you can see it is basically getting installed inside the virtual environment, not outside. Okay, then we can basically either create a Jupyter notebook or you can create a text file. I'll create a text file instead. Okay. Next is you can go and create. You can go and create your own OpenAI key. So like, for example, here, I am right now in CloudxLab, this environment, and I can create a secret key. Okay, I'm going to, hide my screen for a moment and create a new secret key called testing. Okay, so done. I'm sharing the screen again. So when you create a secret key, it basically gives you a prompt like here, right? And create a secret key. Okay, it shows you that, right? I'm going to delete the one that you've already seen. And I'm also going to delete this one. All right. Let me again create my key. Okay. All right, let me share this. Now that key the key is a bit bigger string. It's a secret kind of thing. All right, I've saved it. Let me go back and share my screen again. So now when I create this key, it gave me a prompt to save this key. I've saved it in this file called keys.txt. Okay, this is the file that contains the key. Okay, now I'm going to, this is the key that I've created. I'm going to create a new file. Okay, and I'm going to write my logic here. Okay, and then we'll run it. Okay, let's call, what do you want to call this file? I will keep it in the same folder where I was working. Okay. Okay. Yeah, this one, right? I'll just create this. We'll call it hello LangChain.py. Okay. this is my presentation. So I basically went to this OpenAI and generated the key, kept it in this file called keys.txt. Okay. Now this is basically importing libraries. Okay. And then the second line of code, I'm keeping it in this file. Okay. Or should I just run it right away? I'll just run it right away. Okay. So I'm just saying Python and these two lines. I'm basically importing everything here. I'm importing these two things from LangChain. I imported OpenAI, conversation chain, and all of these. Next, I'm reading the keys from keys.txt and then removing extra space at the end. Okay, let's see if it works. And I'm keeping that in this variable. Okay, let's just see if this variable looks okay. So, okay, the last four letters should be RWQX, right? So how do you do that? Open API key, this one, last four letters, RWQX, but no, RWQX, correct? Okay, that means our key is okay, same as what we have there. Perfect. Moving ahead, then we are defining this template. Okay, template is nothing but, it's like text containing some placeholders. Okay, these are a standard thing in Python to have a template. So you see these three codes. It means that this text is going to be multi-line. Okay, if you want multi-line text in Python, you put three quotes, either double quotes or single quotes. Okay. Okay, that's my prompt. And now this template will work as a standard template for your application. Next thing is we initialize LLM chain. This is the syntax that you should pay attention to. We are saying LLM chain, and we are saying LLM. So we are passing four arguments to it. This particular constructor of LLM chain is taking 4 arguments. First one is LLM. Second one is word prompt. Okay, what does it mean by LLM? It's essentially the entry point. This is where you would use either OpenAI or Anthropic or other models, right? Or Hugging Face, for example, or maybe Google Bard or something like that. So that's a model name you pass. And what are we passing here? We are saying use OpenAI with a temperature of 0. Okay, what does it mean by temperature of 0? Temperature of 0 means do not do any experimentations, just produce the best answer possible. If temperature is more, it will try to generate the text. Okay, if temperature is more, it will try to generate the random text every time you call it. Try calling this one with more temperature. You will see that every time it is giving a different answer. Okay, then we pass the OpenAI key that we just set, and then we are passing the prompt, the verbose equals to true, and this is the memory. Okay, let's see. Okay, so here, this is my prompt. Okay, this is my chain. This is an instance of a chain where we can call it, right? So LLM chain is a chain of multiple prompt. K equals to 2 means it will save in the memory the last 2 questions and responses for the next question. Okay, so here we are saying that use the conversation buffer, meaning when you are sending a question, also send the previous question answers. Okay, because if you think about the OpenAI key, OpenAI, if you go here, take a look at, say, documentation or API reference, and you take a look at the create completion API, right? You will see, okay, you will see that, yeah, this one, if you see, One is what you need to pass is the name of the model. This is OpenAI I'm talking about. So you need to pass the model name, and you have to pass an array of messages comprising of the conversation so far. Okay. So you basically pass the entire chain. So instead of you, keeping this, the entire track, you can let the LLM chain keep this conversation buffer. Okay. All right, let's just do that. So where are we? Right now, we created ChatGPT chain object, this one. Now we are going to say, we are going to run this thing. I want you to act like a Linux terminal, and I'll type command and you will reply with the answer. Okay, let's just take a look. All right. Looks like it did not work for me. Okay. Let me again. Okay. Let me try doing it again. All right. Okay. And what, right? So, okay. So I have saved my keys, and all right, this is the place I've saved my keys. Now, next thing I'm going to do is I'm going to copy paste all my code here so that I can run it quickly. And that's what I'm going to do. Now, moving ahead here. Okay. Okay. And I'll say print output. And then before that, I have this. Okay. All right. Oh, I did not call this template. I only did part of it. I only did part of it. Okay. All right. Looks like we are all set. We imported the libraries. Yes. We defined our key. Yes. Then we define this object. And then we define the template here. And this is my prompt. Yes. So template is there, prompt is there. And then we are passing this. Okay. So I think I got my mistake. Did I? Where is this line? Yep. What did I do? Okay, now it seems to be okay. Import libraries, yes. Define the keys, yes. Template, yes. Prompt, yes. And then I defined the ChatGPT chain, LLM chain, yes. And then I'm asking it to give me the output. I'm saying that, okay, view, and can I wrap do the word wrap? Yes. So I'm asking it to become the Linux terminal. I'm launching it again and see what happens. I see. I see. Okay. All right. Okay, I'm going to again change the key and see if that works. Just give me a moment. All right, let me see if that key works from the other account. Okay. All right. I'm just trying to set up a new key. So yeah. So I've copy pasted the key here. Okay. So now let me just share the screen again. All right. Okay, so this is my screen. Yeah. So basically here I'm reading my keys.txt and again copying everything. Yeah. I've not installed the Jupyter notebook locally yet. Yeah. So now it's working fine. And what you see here is essentially, yeah. So for this, you can see I said present. So basically it's behaving like a Linux terminal for me now. Okay. So that's what we wanted. Okay. So we said I want you to behave like a Linux terminal. We have asked this to ChatGPT, and I will type commands, and you will reply with what the terminal should show. I want you to only reply with the terminal. This is standard prompt, okay? And nothing else. Do not write explanations. Do not type commands unless I instruct you to do so. When I need to tell you something in English, I will do so by putting text inside curly brackets like this. My first command is pwd, so it has actually given the output. When we say print output, it basically gave this, right? Now, let's just go ahead and experiment with more. Okay. We are saying here, human input is ls tilde. Why human input? Remember the template? We kept human input there. Okay. So ls is a command in Linux and it has given the results. It says it has basically nothing in the folders. Okay. And wait, I'll just try to print the output as well. Yeah, the ls has given us this. You see that? ls has given us this. Good. So far, so good. Let's say here, now we are trying this. Okay. Okay. And I'm printing the output. See. Okay. All right. I'm going to do one quick thing. I'll say ask. Okay. And I'll say command. And in this one, what I'm trying to do is I'm going to say this, and here I'm going to pass command and print the output. Perfect. So now I'm going to again ask, ask PWD. You see, it basically said PWD is /home/user, or you can say /home/user, right? And again, I'm going to say ls. Okay, so you can see that it is basically taking care of the context, as well as we are able to interact with it, just like we interact with it in a ChatGPT form. Okay, so now I'm saying this. I just created this function called ask, which does both the things together in a single shot. And let me just remove the double quotes. Okay. Please make a file jokes.txt inside and put some jokes in it. So I'm asking it to create this file, jokes.txt, and write something in it. You see that? Now, you see, it basically created a jokes.txt there inside it, and then it basically kept some joke in that. Now, let me see. Now, I'm going to do is I'm going to ask it to get jokes.txt. Yes. So you can see, yes. So whatever it kept earlier, that's what it has given. That means it is keeping a record of whatever we sent, right? So LangChain, what it is doing when sending a question to OpenAI, it is carrying over last couple of window of the conversation. Okay. All right, you can create a web app using the code above. You can create agents that accomplish a task. You can connect a vector database containing your data and get insights. Okay, that's pretty much for today. And okay, what I want is, right, we are launching this PG certificate course in data science, AI, and data engineering. The AI, as well as the LangChain, as well as the generative AI, all of these parts are covered as part of the course. So feel free to enroll, and you can learn everything from scratch till the point of understanding how exactly ChatGPT gives you the results. So this course is extremely deep. It covers almost everything that's needed to understand the AI and machine learning and data science, and along with data engineering. This is fairly deep course, even though it's only for 8 months, but this is equivalent of any master's course that you will attend. It's a fairly deep and aggressive course. It is explicitly designed for the people who are working professionals. Okay. Perfect. Let me, if you have any more questions, you can come over to discuss.CloudxLab and ask there. Let me take a look at the Q&A window. A question from anonymous attendee: how to change prompt template to support user item collaborative filtering. You won't be able to do that just by using prompt engineering. If you have like a small data having a couple of users, couple of items, then you can just do the prompt engineering. But if you have like thousands of users, thousands of products, and you want to do user item collaborative filtering, the way I explained, you need to look at embeddings and you need to look into more details. Okay. A question from Lokesh is, what's the cost of course? I want you to reach out, take a look at the website, and you will get to know about the cost. Okay, great. Yes. Thank you, everyone. We give the placement assistance in the form that we conduct the exam, and then we connect you to the recruiters. Okay. So thank you, everyone. And a question from Sutapa is, what's the start date and end date of the course? Come over to the website and the one that Shubha shared above. Okay. And feel free to ask questions there. All right. Wonderful. Wonderful. Okay. All right. Feel free to ask any questions. Okay. Thank you, everyone. Stay tuned. Come over to CloudxLab, do the experiments, and whatever we did today, do that in your free time. And this is very much possible to do it on the CloudxLab itself. So do that. Okay. Thank you, everyone. Have a good day. Is there any other question, team, that I need to answer?
No.
Okay. Thank you, Shubh. Thank you, Sachin, in this call. I'm really thankful to you guys to take care of the Q&A. And thank you, everyone, to make it happen. I'm really glad that more than 50 people in Zoom and around 50 people on YouTube, they were attending the entire class for 2 hours. And feel free to reach out to us. And if you have any doubts, you basically can get those clarified by the team. Okay, so thank you, everyone. And get in touch. Most of our sessions are interactive. We answer questions and do the hands-on in the classes.